Hello, I'm Dr. James Dborin, one of the co-founders at DoubleWord AI, and we're back with another episode of the Behind the Stack series where we talk about all the necessary components needed in self-hosting language models. And today we're going to be talking about the problem of evaluations and figuring out how you can evaluate how good open source models are, in particularly compared to closed source models provided by people like OpenAI and Anthropic. So there are lots of ways to go about this problem. The gold standard way, the only real way to do this completely error-free, if that's possible at all, would be to create some sort of in-house evaluation where you take the task that you're interested in, might be a RAG task, an agent task, data processing, data extraction, whatever it might be. You get your example documents, example queries, example environments, run the language model in that environment, get the results, and compare it to some known gold standard set of results that you can verify by hand are correct. And then you can compare open source and closed source models and see how close they actually are. You can try fine-tuning and have a good sense of how close you get to the best proprietary models with smaller open source models. But the problem with this is that it's really difficult. It takes a lot of effort. It can be costly. And probably most difficult of all is that if you don't have a good understanding of your task yet, you don't quite know where value from language models are going to come, it's usually not worth the investment. It takes a lot of time to get it right, and the project might just be scrapped if it doesn't work anyway. And so you need a good general purpose way of telling which models are good and which models are bad at a glance. And this is especially true as new models come out every few months. They're not always just straight upgrades. New open source models come from new providers, and it's difficult to tell which ones are best and if you should switch. And so we need good general purpose ways of telling these models apart. One common tool is benchmarks. You can look at scores on reasoning benchmarks, programming benchmarks, math benchmarks, general purpose knowledge, things like that, and use those to compare models. But the problem with this is that it's not always entirely clear that better benchmark scores result in better downstream user appreciation of these models. It often does. They quite closely correlate, otherwise we wouldn't use the benchmarks, but it's possible for models to get better on these benchmarks without becoming better on your task at all. Especially if it's user-facing. A lot of times what you care about is some of the stylistic properties of the model, not necessarily just its raw knowledge. If you're doing something like RAG, you're going to be injecting knowledge, so maybe you don't care so much about the model's general purpose knowledge and things like that. Sometimes these benchmarks don't work. So in this video, we're going to be talking about my personal favorite way of comparing models, comparing different types of models from different providers when they come out. And we're going to use this as an example exercise of saying how good are some of the open source models that are available today compared to their closed source variants. This is a basically impossible question to answer in general, but we're going to talk through how I use this one particular tool to do that. And the tool that we're going to be using is the LM Arena from the LM team. So I've taken a bunch of screenshots from the website, and you can find them by searching LM Arena on your favorite search engine. And what the LM Arena does is it tries to provide real user feedback on all sorts of models, closed source and open source, by blind ranking different answers from different models against a single user query. So we'll dive into how you use the tool now and then talk about some pros and cons at the end. So here on the screen you see the arena as you'd see it when you go to it. So this is the text arena. So this is just looking at text in, text out queries. There are similar arenas for image generation, for reasoning over images, but this is the most popular one with the most total number of votes. So these are probably the most reliable results and include the largest selection of available models. So what you see is we have the models ranked in order. So higher is better. At the top you see Google's largest models, the Gemini Pro. You see OpenAI's reasoning models and the ChatGPT models. At the time of taking the screenshot, GPT-4 wasn't out, and so Those aren't included in here, but if you go now, it will reflect the new models that have been released. And next to them, you see a score. So this score is an ELO score. It's similar to the score that you see, that you might see like they rank chess players as. And you generate these scores with head-to-head comparisons. So a single user will ask a prompt. You'll get 2 responses back from 2 different models, which are hidden to the user, and the user says which one they prefer. And when one model beats another, this goes into a big data set, and the score is essentially a reflection of which model is more likely to win than the other. So one way to read it is to say, like, if one model's score is higher than another, 1459 compared to 1428, then on average, users have a preference for the Gemini 2.5 Pro model over the Grok 4 model. For example, if they're the same, then in general, it means that they're about 50-50. It doesn't always work out exactly that way. It's sort of fit on a sort of like a regression on a big data set, so it's not guaranteed to be that way, but that's how you read it. If two numbers are roughly equal, then in general, users prefer one or the other about 50% of the time. So the higher the number, the bigger the difference between the two numbers, the more likely it is that users will prefer that model. And so over time, they build up votes for each of the model, and then you get this nice ranking of the models based on how much users like them. So the people who make the LM Arena have done a lot of good work on this, and they classify the prompts into different categories down here. So you can look at prompts that are related to maths or instruction following or multi-turn instructions or coding or long queries, or there's different languages and things like that. And so if you have a better idea of what task you want to do, you can always filter the responses to only be for these particular categories and then see a user preference within the category that you care about. And they have plots like this, which actually break down the individual win rates, but only of the most popular models. So in this case, we've highlighted, for example, the Qwen model versus Claude Opus 4 from this date, and it has a win rate of about 73%. So in this case, 3/4 of the time users preferred, I think this means users preferred the Qwen model, but I'm not actually 100% sure. Either way, one of the models was preferred 73% of the time to the other, and you can see the breakdown in these sorts of charts here. So here's a screenshot of what the actual battles look like. So a user asks a prompt. In this case, I asked the prompt that sort of inspired this video, like how should I choose which LLM to use? And then I get 2 responses from 2 different models. One on the left, one on the right, just labeled Assistant A and Assistant B. And then I can choose that the left is better, they're about as good as each other, they're both bad, or the right is better, and then this goes into a big data set, they perform regressions on it, and then they get these ELO scores, and this goes into usefully ranking which model is better or worse. So I'm going to walk through what the process looks like when, let's say, a new model comes out and you want to see how good it is and compare it to other models out in the world to see if it's maybe worthwhile switching from your proprietary model to an open source model, modulo all the other sort of costs and difficulties associated with that, or from switching from one open source model to another. And so we're going to go through this example of how you might use this tool when the Qwen 3 models were released, for example. So when Qwen released their Qwen 3 series of models, after a few weeks, these had enough votes on the LM Arena to sort of have meaningful statistics. And now you can use these to try and answer this question. So in the sort of search bar there, we put in the Qwen 3 and you get these 2 results back. These are, I'm interested mostly in the 30B variants. If you look in the top models here, there's actually quite a few open source models. You have the top one obviously being this Qwen 3, and the Kimi K2 models, the DeepSeek models, and the GLM models. But all these are much larger, a bit more difficult to self-host without significant resources. But as part of the release, the Qwen team also released this 30 billion parameter model, which is very easy to self-host. You could easily do this on even particularly well-specced out MacBooks or something like that. So they have 30 billion parameters. They activate 3 billion parameters, so it takes the memory of 30 billion parameters, which could easily be hosted in a single large GPU, like a H100, but the latency feels closer to a 3 billion parameter model. So this is a really nice target for self-hosting. And so we filtered for these models in the overall category, and we get these results. And in particular, we get these two ELO scores, 1378 and 1328, for the instruct and base variants. And so we can go about now comparing these to other models. If we look at one of the sort of best series of easily hostable open source models, the Gemma 3 models from Google, we can look at these models here and look at the relevant scores. So if we compare the Qwen 30B to the Gemma 27B, you see that despite being similarly difficult, they have similar memory requirements, 27 billion versus 30 billion. They have very similar scores. The Qwen model looks like it just about edges them out, but with the confidence intervals, they're probably about the same. But because this is an MOE model that only activates a fraction of the parameters for local usage, for usage with small number of users, the Qwen model will feel much faster, have much lower latency than the Gemma model. And so this is probably quite a good switch. And in fact, it will sort of feel closer to this 4 billion parameter model, maybe just about in terms of latency numbers, but has a significantly higher ELO score than it. So even though this one requires much less memory, it might be a worthwhile switch. It might give you sort of a nice benefit of the speed feel of that, the intelligence of that, with similar hosting costs. So that's the kind of question you can ask with that's the sort of question you might ask when you want to switch to a different open source model. The other interesting thing we can do is we can compare it to closed source models. So here I've taken a set of closed source models from Anthropic, the Sonnet series of models, and the 4o series of models from OpenAI. And I want to compare them to this 30B Qwen 3 model. So if we look at its ELO of 1378, this is quite significantly far behind the latest version of ChatGPT 4o and Sonnet 4. But what's interesting to look at is that actually it's about as good as the Sonnet models as of early 2025. And it's actually significantly better than the GPT-4 models at their release in late 2024. So these models get better over time. Like OpenAI is constantly improving their models, as is Anthropic, and releasing sort of updated versions. But at the time, these models were state of the art. They were extremely good. They solved tons of challenges. And now you can get a model as good or better than them as per this LM Arena score that can easily be self-hosted locally on very limited hardware. And this is an interesting result of this, of looking at these sorts of comparisons, because the LM Arena very kindly sort of keeps up to date, or keeps historical versions of these models, so you can sort of see back into the past a bit, and how good would this model have felt had it been released at the same time as 4o. You know, it would have matched the quality of these models according to these LM Arena scores. So that's a bit about sort of the mechanics of using the LM Arena and what kind of questions you can ask. So let's dig in a bit to the pros and cons of working with this. So the pros of the LM Arena approach of real users blind ranking these results is it's sort of much more closely aligned to the real way that these models are going to be evaluated in real life. So it's kind of harder to hack than benchmarks. If you train on benchmarks, if you give similar queries to the benchmarks or questions that rely on the same knowledge to the benchmark, the models are going to improve in the benchmarks, but they're not necessarily going to improve in things you don't care about. But the act of making humans like the output is kind of the whole goal. So in some sense, reward hacking on the LM Arena is kind of what you want to happen, but you don't want that to happen on the benchmark. So in some ways, it's like a better aligned to human preference than a lot of other ways of measuring models. And the other thing is that it's much harder to hack. By which I mean artificially inflate your score without making the model better. Like the act of making the model prefer, or making humans prefer the output is kind of the whole game. And so these are the pros of this like approach, I think, is that it's just kind of much more aligned to what we actually want out of these models. But it's not perfect. There are biases in the people who use the LM Arena. It's not a particularly well-known tool. It only has 3 million votes. And there are sort of well-known examples of biases within this. So for example, they report on the website that I think longer responses tend to get more votes, as do responses formatted with better markdown. And they actually provide ways to try and control for this. But if you care about tasks where the outputs are short, or the outputs are in JSON format, or the outputs don't align to the biases of the people using it, then this is going to be, again, a less useful tool for you, because it doesn't align with your use cases. The other thing is they don't have all models on the LM Arena, especially if you're in a sort of specialist domain, maybe therapeutics or sort of similar things that people tend to fine-tune models specifically to do. For example, Google even has their sort of like TX Gemma series for therapeutics. These don't tend to appear on these lists just because they're not general purpose enough. And so once again, these scores can miss this. And then finally, it's not unhackable in its entirety. There are people who claim that that especially some of these bigger labs try to like improve their LM Arena by sort of training on some of the outputs. Or there was a scandal with Llama 4 where they released a version to the LM Arena which was specifically trained for LM Arena responses, and then the one they released to the general public wasn't the same model, and so it maybe looked like it had artificially inflated LM Arena scores, and so you can't trust these 100%, but this is like harder to break than the benchmark scores, which are a bit easier to break. And ultimately, if you are in a specialist industry or need the models to do something that's other than sort of like chatbot functionalities, you're eventually, to get a perfect understanding of which models are better, you're going to have to build your own evaluations, maybe build an internal tool a bit like this to get A/B testing feedback on different models' responses and things like that. But the LM Arena, despite some of these negatives, is by far my favorite tool for comparing models, like general purpose tool for comparing models. And so if you're looking to make a switch or are curious what other models you could try, open source or closed source, I would definitely recommend this as the first place to try to get a good sense of the quality of these models.